Yes, perfect. That's my cue that my presentation is about to start. Everything in this life, at least for the last couple years, for better or for worse, starts with a tweet. Believe me or not. So, and this talk also, idea of this talk actually came out from the tweet from one of community members in the Apache community, Apache Pinot community, and he was asking, well, there will be some new improvements coming into framework that we're going to be touching a little bit today, called Kafka Streams. Is it the right approach for querying the stream, or it's better to use something called like a real-time analytical database, like Apache Pinot? And you must be wondering, like, why I started this. This is kind of a weird way to start the conversation, but you will get there at some point. A friend of mine and colleague, he actually replied to this tweet and saying, like, that would be a good idea for a talk. And this is how this talk came about, because everything that happens with the person who has a slight the inclination towards DHD, you go in very quickly in the rabbit hole. So that's why it started with one simple question, like, should I use one versus another? Now you have a ton of technologies that we're going to uncover. Welcome to One Does Not Simply Query a Stream. Does anyone get the reference? Anyone old enough to remember old memes, like classical memes from the Lord of the Rings era? And also, since it's a 2025, I obligated to use AI or mention AI at some point, right? So all the slides, what the hell is happening with my phone? My phone is just sliding down. What is happening? How? Am I my vibrations, or maybe some particles moving and they, grabbing the phone? I don't know what is going on. Yes. The also was very inspired by some 8-bit games, specifically Vampire Survivor that I was playing for quite some time. My name is Viktor Gamov. I work as a principal developer advocate at a company called Confluent. Confluent was started by original creators of Apache Kafka, and on top of all these things, we built the best, probably the best, the managed service for Apache Kafka, a streaming platform for ingesting data, processing data. It's called Confluent Cloud, but we're not going to talk about Confluent Cloud today. We're going to talk about how to query the stream. Everything that, at least when I was a little bit younger in my university times, I learning databases, and this is kind of like was the approach for you storing data for a long time. Like, we learn all the things about ACID transactions, we learn all the things about durability of the data. Maybe some of us were like lucky enough to start building distributed systems. You quickly learn about replication or partition or sharding of the database, how you can run this. But essentially, everything stayed the same, because for application developers, there was a language. There was a language to deal with. And usually it was a SQL, and it was generally standard. And the people learned to build apps this way. Kind of, they're expecting some query language, ideally something familiar, that would exist. So you have your application logic, you have your queries written in SQL, and life is good. Everything is perfect. We're happy, but we grow in systems. We're integrating with other systems. And in order to move data around, so that's why I mentioned replication a couple of seconds ago, moving data around the system, we start implementing tools like ETL tools that extract the data from source database, do some transformation, and load back into a new database, because their developers, they have language to query this, maybe that they don't understand the SQL that you understand in your database. Another approach how we can kind of like extract the data from one place and move to another place is called the change data capture, or CDC. Essentially, your database provides some API, so the system can tap it, and everything that happens with database will generate event. And this event would be published in the CDC system that will transfer it to another place where it will be materialized in the form of this change came in. Now it would be table update or something like that. Everything was good at the point where the data exploded. All these technologies start working great at the point where they stopped working because of the sheer size of the things. Everyone has a device that can go to internet. Number of or amount of data that generates every day is constantly growing. So it's not fun to be this small monolithic database that you can query. Now, we're going into world of data pipelines and maybe even event-driven microservices if you lucky enough to start like a slicing dicing this monolithic application and turn this into microservices. And general consensus among the people that append-only data structure is a great solution for performing this type of communications. The same idea was basically inspired by initial implementation of the databases. Inside database, you have this kind of like a append-only file that all operations will go, and these operations materialize in the form of table. And essentially, Kafka is a distributed log. Log is a data structure where you have messages that you're not changing, and you're always writing in. And the pattern of reading this data is also interesting because there's no random access of this log. So it's a great system for scalable data exchange, but how to query this? Now, like people who have a mentality of we need to use something to query this log. How we can do this, we don't know because it's something new. And we didn't expect this to be fully change the mindset how we're dealing with the data. Anyone using Apache Kafka today or any type of streaming solution? Maybe Pulsar, Kinesis, the RabbitMQ unfortunately is not considered as a data streaming solution, things like that. I'm going to be talking about Kafka, some of the things applicable to other systems, but some of the Kafka-specific things, they will have a Kafka something in their name, and you will understand that they only work in Kafka. And also, for the query side of things, there's two types of, I can at least like separate two types of queries that you can perform. One is transactional queries, when essentially you have information about certain entity. You have a credit card number, and based on the credit card number, you want to see recent transactions. So you do select star from table, you have a transactions where credit card number equals something, and you have some predicate that defines from what time window you want to extract this data. Another type of queries is analytical queries, where you don't really care about individual message, you care about whole story. Instead of finding particular transactions, you would be interested in answering the questions, what percentage of my spending that happens seriously though? Like, what is going on? Okay, so it is serious, something is happening. I don't know, what is it? That's weird. Totally unprepared. You have the story to tell about this data. Say, what kind of percentage of your spending you spent on entertainment and how much you spent on the grocery. This is analytical query that gives you answer based on your data. So we're going to be touching two aspects of querying this stream. First aspect is the transactional, essentially how we can find individual records if we care to find those. And the second one is how we can tell a story based on some data that we have in the stream. So that's kind of like a premise, so that's why I will be touching these things. Now, back to the conversation. Since we started this conversation with mentioning things called Kafka Streams, I decided to, okay, so let me do even one more step back. We're going to start with some of the solutions that are available out of the box. For example, something that may be available today and you didn't know that you can use it for query the stream. Something that, what I like to call in-store brand. Something that comes as a battery is included into framework. So we're going to talk about Kafka Streams. Anyone using Kafka Connect these days? All right, one person. Kafka Streams maybe? Or a few people, okay. Streaming SQL. For the last 5 years, a new category of software started emerging where we're going to talk about this. It's actually very interesting, and I do have a few ideas how to characterize if it's a streaming database, like streaming SQL database, or it's not. We're going to touch about interesting thing that also started happening for the last 5 years. It's called real-time OLAP databases, or real-time analytical database. Sounds like a little bit oxymoron, a little bit, right? Because it's a real-time, but also analytical. Like how this work? Usual suspects like data warehouses, believe me or not, they also provide a solution that you can use to query particular stream of data that comes into Kafka. And we're going to talk a little bit about the data lake as well. Now, the Kafka Connect. So when everything started on the Kafka side of things, were only like 2 APIs. One API is producer API, consumer API. So you want to write something into Kafka using producer API to send the record, and you have a consumer to read this record. Very soon, people realized that they need to bring the data from different systems, and it would be tedious to every time for every new project they need to write same code that will be reading or like constantly in the loop, querying your database, and after that moving or your file system or your whatever system or maybe API and pushing data into Kafka. So the community came up with this idea of the framework called Kafka Connect that will be handling some of the low-level stuff. For example, how to scale these readers and writers, how to deal with schemas, how to do some transformation of the data. And as a developer, and right now mostly it's either open source or vendor-specific implementations. For example, vendor will give integration that work with Kafka Connect. And you as a user or data engineer who supports this pipeline, they will just like, okay, we're going to start this connector. We're going to use this connector. And in this particular case, that's it. That's pretty much everything what you need. You have a Kafka, you have a Kafka connector. You dump this data into database that you know how to work with. Everyone is happy. You can still use whatever tools to query this database. And interesting thing that Kafka Connect will be constantly, from the reading data from Kafka topics, will be constantly updating this database. Data freshness questions and latency of the queries, and when you try to run all these type of things in your databases, that's already something that you need to start considering. And how you're going to be dealing with situation where you need to perform either transactional queries or you need to perform aggregations or analytical things. Some like traditional databases that many of us use, they follow pattern of being OLTP, online transaction processing databases that focus around implemented ACID transactions, focus around handling particular records, right? MySQL, Postgres, all these things. However, you still will be able to run some analytical queries, but usually it's not something that even, I don't want to say, any loud words, but it's kind of so cumbersome. And sometimes even time-consuming, performance-consuming. Sometimes you can even kill instances of your databases. So maybe this is not the right solution for this particular case. That's why I mentioned that it's suitable for smaller data, relatively small. You still will be able to query a couple gigabytes, and you still will be able to do reasonable, okay on the latency side of things of those queries, especially if it's analytical queries, especially if you have a properly indexed data. So it might be suitable. Historically, it is transactional streams that we're dealing with, and many users are familiar with this. Before I jump in, I'll show you a very quick code snippet that will be representing how this would look like, how your configuration would look like. Essentially, a connector will be running next to Kafka. It's not something that you're running on the same broker nodes that Kafka. It's a separate process. It can be run, say, in Docker. In this particular case, this image will contain a connector that knows how to connect to particular database. In this particular case, I'm using JDBC connector, and I'm using, say, I know how to query SQLite because it's easy. It's one of the popular databases. There's different tools how I can query. So this connector will be reading data from my Kafka topic, writing data into this file, and after that, I will be able to query this. Now, This is something that's very cool because Kafka Connect can handle some of the cool things like a schema evolution. If based on the data, the incoming data, data change in Kafka topic and update happened in schema, this connector can update schema on the underlying database. But still, it is cumbersome to deal with the real-time data. Another representative of what I called in-store brand called Kafka Streams. And Kafka Streams is a library that you can embed in your application. And this library allows you to perform stream processing computation. So you are technically not querying the stream, you getting all the data, doing something with the data, and sending the result back to stream. The best explain how the Kafka Streams and Kafka Connect and Kafka work together is explanation. I think the creators of all these tools, they were inspired by this the Linux mindset, where you have one thing, and this one thing would be done the best way, and after that you combine multiple different tools to perform some of the complex things. So that's why we have pipes in Unix, and we have the input and output. We can get this from files, from socket, from everywhere, and we can pipe this into some of the processing. It can be some command line tool that process. Same thing with Kafka, Kafka Connect, and Kafka Streams. So Kafka is your pipes. Kafka Connect, it's the redirection of input and output of the commands, and Kafka Streams is your processing application, like TR, AWK, SED, and all these things that you're available in UI. And the Kafka Streams has very, very, very intimate relationship with Kafka, and a lot of architecture decisions that were made in order to scale your Kafka Streams application or perform fault-tolerant storage on the Kafka Stream application, also very tightly tied into Kafka topic. The way how you're scaling this, the scalability of your Kafka Streams application will depend on number of partitions in your Kafka topic. There is a abstractions that turn the stream of data into something that would represent point of time materialized representation of the data called key table. And the key table is something that you can think about this as a table, but you will not be able to perform any arbitrary queries. You will be able to do queries by particular key because, again, this thing is tightly coupled with Kafka architecture. Every record in Kafka topic will be represented by a key value in some additional metadata like timestamps and the partition ID and all these kind of things. And that's why this key table more give you feeling of the hash map. You need to know the key in order to query this data. It's fine if it's a transactional use case. You already know the key that you're trying to query. You're trying to find particular credit card transaction and you get number or set of transactions in the credit card, you will be able to accumulate, or rather you will be doing something like a balance, because you're not query stream, you're querying this table, and table will represent like one particular thing. It's a memory. It's backed by RocksDB and also replicated through Kafka for fault tolerance. If one of the nodes will go down, this state would be restored, and you will be able to continue on another node. This is very important. If you ever try to use Kafka Streams, if you ever try to scale it, obviously you probably already know what I'm talking about. It's usually, again, very tightly coupled with the Kafka consumer group architecture. And there's good things, like good parts, and bad parts that are this Kafka integration introduces some of the things that you cannot change if you don't like them, because they are architecturally built in the framework. And there's the concept of interactive queries that you can put in your application, expose it through REST, and after that, the provide the contents of your state store into outside world. And this is how the code would look like. We're getting the data from the stream, and by calling this to table, we transform in stream to table. We can do another kind of, we can turn table into stream. The best example to stream table duality is where you play any chess, and state of the board, that's your table. And everyone who record all these steps or all the moves of different teams, that's your stream. In case of something happens, your state will be destroyed. You still have a list of moves written down on the piece of paper, so you will be able to replay this log, replay this stream, and restore the state. When you do moves on the table, you're changing the state, it can generate change event that will be written down into a log of operation. So hopefully this is something that you will take out from this talk, so you will understand what is the particle and wave duality, the stream to table duality between in Kafka. Analytical use case, you still will be able to perform some of the aggregations. Kafka Streams is the stream processing framework that supports stateful stream processing, meaning that we have some sort of like a memory of the past. We know, so in order to calculate some of the aggregates, we need to know what happened before. So it provides this way, but still query by key. It's not something that will be perform some sort of the arbitrary queries. The way how it would look, let me show you on a bigger screen. On the Kafka Stream side of things, you are tied to Java. And this is what you usually write. This is what we call the direct acyclic graph. That is represent data flow. We have a beginning of this graph and the end of this graph that will represent Kafka topic on both sides. And in between, it's operations that happen on this pipeline. So we can do operations that are stateless. For example, flat map will just take a stream of sentences and explode it into stream of words, because we're gonna parse this sentence and extract the words. After that, we will shuffle things around in order to group words with the same words on one particular node or one particular partition. So we will be able to perform aggregation at the end. And after that, we can materialize it in something what we call a state store. And this state store can be wrapped into something like REST API. And if you're calling this REST API, state of this application will be available to outside world to consume. So they don't need to know Kafka, for example, to query. That's already takes us somewhere outside to where we can explore. However, again, some people are saying, but Viktor, kind of like, you start with SQL, what's up with this Java stuff? Like, we don't like it, or for some reasons, like every new use case will require writing the new application, which is also cumbersome. You need to write this, compile this, test it, deploy it. So I love Kafka Streams. Kafka Streams is a great framework for event streaming, event-driven microservices, because it provides a lot of low-level functions, the high-level abstractions that allow you not writing this from scratch using producer-consumer. However, for the sake of like querying the stream, we can do better. I hope. So, streaming SQL. Now you see in the picture, we have a log that flows through stream. I'm trying to also come up with something, the pictures that would be slightly relevant to conversation of this particular chapter. So, streaming SQL databases. This is something very, very interesting. And I would say the clear definition of this streaming SQL database would be something that can describe it is you have integration with streaming source. It can be Kafka, Pulsar, Kinesis. It has a SQL as a language to query the data, but also the system will have a storage that will allow us to create persistent materialized views on top of the data that comes from the stream. So I think that's kind of like simple, will give you idea what we're looking here. And all the systems, they will have ability to create this materialized views and query these views afterwards, considering all the new data that comes from Kafka also will be materialized. Now, I'm going to talk about a few things. Materialize is one of the products. Anyone heard about this? Materialize? Maybe someone used this? One person? Okay. Delta Stream, it's kind of also Interesting solution. That's cloud native. Anyone Delta Stream? No. Okay. Rising Wave. Few people. Rising Wave is pretty cool. It is. I'll talk about this. And KsqlDB. Anyone heard about KsqlDB? Used? Okay, few people. Nice. Okay, that's warms my heart. We're gonna talk about all these things. There is also yesterday I did this presentation in Zurich, and few people came to me and they suggested to look on some other solutions. For example, Time Plus. Anyone using Time Plus? Okay, we're gonna talk about this at the end if I'll have a question. Have a time. Some people can ask, what about Apache Flink? Any Flink users in this room? Okay, one person, two people. Same people who were using the previous technologies. Good. It's my people in the room. They tried everything. They hate everything, and that's why they're saying, okay, what Viktor will tell us. Now, Apache Flink is not streaming database, and I'm ready to fight this because Apache Flink is a stream processing framework. It's a cluster-based stream processing framework, but uses SQL as a language to interact or to compile down to the data stream API that will be represented in these operators and how the things will be deployed. If you want to know more about this and why Apache Flink is not database, David Anderson, he is one of the, if you will go to Stack Overflow and start searching some Flink questions, this gentleman would be there somewhere answering the questions and people will be happy with his answers. He did the video. It's a 10-minute video. If you want to understand Kafka, how the Flink is not streaming database, but still cool technology that you need to pay attention in 2025. Please go there, subscribe to YouTube channel, write down the comment that Viktor sent you, and we're gonna move on. Now, and which brings me to not super far from our previous subject, not super far from the Kafka Streams. At some point, we at Confluent, we got this idea, okay, so Kafka Streams is cool, but people hate Java. But we love Kafka Streams, and what if we will give people ability to writing this, a Kafka Streams application without writing Kafka Streams application? We'll take care of deployment, we'll take care of the compilation of this topology. So that was the idea, to bring the streaming SQL into Kafka. So, and I put this streaming database for the sake of kind of saying, because remember, three things: streaming is the support of the SQL, integration with streaming platform, and storage. So KsqlDB, very interesting. Very interesting the exhibit in my presentation here, because yes, it provides you with streaming SQL. However, it's highly customized. You need to learn a little bit more, few words that it introduces. A second thing, it integrates with Kafka. It built on top of Kafka Streams, so it has intimate relationship with Kafka. A lot of things that how the KsqlDB scales also depend on how Kafka Stream scales, and some of the bad parts also would be inherited here. Specifically, if you have a huge store that you need to restart during the application restart, it can take the minutes or to populate the store, and this is something unacceptable in many cases. It provides the persistent concept of the table that also inherited from the concept of a key table, but in this case, it allows you query arbitrary fields, not only by key, which is pretty cool. So it can solve some of the use cases for transactions. They have two types of queries: pull and push query. Pull query, every time you're writing select start, that's your pull query. Every time you're getting this result, you get some data set, and off you go. Push query is something that you can build application on top of, and this push query will constantly get the results to your application. Yeah, like Kafka Streams, but SQL. The way how it looks like, just a little quick, so we will not spend much of the time there. With KsqlDB, you will have something like this. So create a stream. This is how we're reading stuff from Kafka. if we want to perform some sort of like aggregation and have this table, and this data will be available stored inside this in-memory key table and backed by Kafka as a table, so you can do this. And this is essentially you describing how you do your stream processing performance. And you can write this stream back into Kafka topic. So the little bit like create stream, for example, it's some custom name that's not available as standard SQL. So in order to show you what, say, Flink does in this particular case, Flink has the concept of the table. There's no concept of the stream in here because there's no stream word in standard SQL. But this is how the Flink does connection to Kafka, and this is how the Flink does actual computation. So it's similar-ish, maybe different words would be used, explode, split, and KsqlDB use words like split and unnest, and so far so on. So materialize. It is a implementation of timely data flow. That was a paper back a few years back from the Microsoft, how to perform the stream processing. I think it's also implemented in Rust or something like a cool. But their most use cases, they are around the streaming analytics, building kind of like a replacement of your data warehouse with streaming analytics. Integrates with Kafka natively. Materialized View is a central abstraction. It has its own storage. Everything is stored and materialized and persistent. Now, the cool thing that you will see, I think this is another very interesting point that the streaming databases also exhibit, is that they trying to provide or meet developers where they are and providing the ways how the people can integrate existing tooling. So that's why supporting of the Postgres wire protocol allows to just existing tool to use against this materialized thing. It doesn't mean that you can use whatever Postgres queries that you're using. It only means that the tool that communicates, send the queries and read the queries back and parses results will work. You still need to write the queries that will comply with materialized. But still, it's a pretty cool thing to have so you can use your favorite tools. Delta Stream. So some of the people who came up with KsQL, they come up with this idea. What if we would be unburned of the limitations of supporting every possible platform or running this on a different hardware and software combinations that our customers support? What if it's going to be only cloud native and the people would use same kind of like same mindset that with the queries for streaming SQL, but it would be only cloud native. So, and the funny thing is that the person who started KsQL back in the day at Confluent, he quit Confluent and he started Delta Stream company to build this the cloud native streaming database. So they have a concept of bring your own cluster that essentially allows them to run the control plane on their side of things, but you running your agents next to your data, and you will have a kind of liberty to preserve and making sure like a nice fuzzy feeling about that, oh, my data is not going anywhere, so we're going to be performing the queries on top of your data. Integration with Kafka Kinesis, so it is streaming sources supported. Also have a concept of materialized use, but use for streaming pipelines, and this is streaming analytics is the use case where they use this one. Rising Wave. It's a distributed streaming the database. It has an open source version. It has a cloud managed solution, and it's a stretch. You know, sometimes people get very angry about this, saying that, no, it's not implementation of Flink. Some of the ideas of the Flink were implemented in Rust, and Rising Wave also it's a database because it has a concept of persistent views as well, and this is how the Flink would look like if the Flink would have the queryable store functionality not deprecated or something that people will continue to develop this. So for Rising Wave, again, we're dealing with SQL that is similar, right? So you can figure out like how you can data from Kafka. In this particular case, they use source as a notion of how to bring data in, and they also have a sync, something that they will use to push data outside. And also, there is a materialized view that would use same approach. I'm just intentionally use same use case, word count, but implemented in the different languages for different platforms. So they have a nest, but they have a split. They decided to call a regex split to array. And that's how you perform stuff on. And this view with word counts will be available for querying. So you can also plug your Postgres client, and you will be able to go. You can switch your applications that already have your JDBC driver for Postgres. You just need to fire queries that will be compatible with this, and you will be able to swap into streaming database in your application world. Now, this is our presentations of streaming databases. Now, in the past I spent some time working at a company called Sartre that were founded by creators of a new type of database called real-time analytical database called Apache Pinot. Hence the gentleman with the glass of Pinot, presumably. With Apache Pinot, we're going into interesting new route. At the LinkedIn, they were very concerned about people not using LinkedIn as a social network. So they were thinking about how we can improve engagement on the platform. So they start introducing some of the cool features. If you didn't know, or maybe you knew this, and I will remind this to you, everything that happens on LinkedIn fires an event, and this event will be stored in one big Kafka. Kafka was invented in LinkedIn, and it's still used in LinkedIn. Every time you go into the page and you go in through a list of your contacts, maybe reading some other post or you're commenting something, it will generate an event. What if we can take those events and start building some of the interesting functionality on top of it, like who viewed my profile? Anyone using LinkedIn in this audience? Great, great. There would be a very important slide at the end. I really need your help in the LinkedIn. How many of you use who viewed my profile? All right, nobody. How many of you Google yourself? All right, few people. Yeah, I do this for work, so not just to indulge my inner narcissist and stuff like. No, it's not about that. Friend of mine though, he likes to use the who viewed your profile, my profile after he does either interview or some of the conversations with the companies that allows to him to understand how this conversation happened, and time frame between when the conversation happened and someone viewed profile should be relatively small, like minutes ideally. So that's one of the characteristics of the real-time analytics. So you're still running the analytical query, because in who viewed my profile you have a multiple dimensions. You can see first of all a time series, like when this happened. You can see companies, you can see geographies, you can see a level of people who viewed your profile. Maybe it's C-level, VP level, whatever. So it's an analytical query with the freshness, ideally also minutes, and high concurrency. This use case is deployed for many thousands of users on LinkedIn, and they all check in like who viewed my profile. And this is where purposely built Apache Pinot was created at LinkedIn. System is designed for high concurrency, low latency, ingest data from batch and streaming sources. Remember, I told you that there's everything that happens in LinkedIn happens in Kafka. So these events that are happening there, we need to ingest this in real time. And this is actually a very great tool for querying the stream, because it has a native integration with Kafka, and it's among other tools. I think it's the best implementation, the way how it's handled and how Kafka topics aligned with the I forgot the name of the shards inside the Pinot segments, inside the segments in Pinot, and it will not kind of like a limit throughput because of the size of partitions, because the Pinot has its own model how the tables would be split into segments. And it's just a SQL. Like it's a normal SQL. There's no tricks. It's a database. It's an analytical database. The blah blah blah. These use cases for user-facing analytics you can see this more and more that happen in implementation of those use cases. What I personally like about this, the Pinot thing, is that this can be your last mile database. This is something database that can power last mile, power your API server, power your UI, your dashboards, because it was designed for high concurrency. So it will not suffering from the thousands of people trying to execute this particular query. So it's designed to be used in that way. Now, this is something that I intentionally try to avoid it all my life, dealing with something like data warehouses. I don't have much say about those technologies except one thing, and one thing in common, that they all use blue logos. Even like Amazon Redshift using blue logo. I don't get it. Sometimes when I feel that maybe I'm doing something wrong with my life and my work and I get despaired, I remember that in these big companies, there would be meeting for 10 people, 20 people to decide what kind of grade of blue this logo would look like. And I feel good about myself and stuff what I do. So, jokes aside, essentially implementation of data warehouse technology that runs inside the cloud. BigQuery, Snowflake, all these things, that's your cloud warehouse. Ingestion from streaming sources supported, ingestion from batch sources supported. Data needs to be structured, schema integration, but they inherently created for batch access. And also, the integration with those systems can happen either through Connect. Kafka Connect has connectors for all the systems in order to populate data to Kafka. Now, data lake. As you can see, it's a lake, and there's the books in the lake, so it's a data lake. Data lake is a system what started as, okay, so let's put everything in GFS, and whenever we need this, sometime we will figure out. And many of us know, if you ever use data lake or like system like this, time it never happens. But we know the data is there. So it's not leaning towards the unstructured data. It's more on kind of like we write the data, and whenever we're going to be reading, we're going to be figuring this out. And this is what kind of schema on read or ELT type of pattern when you extract, load, and after then transform when you're reading this data back. They started as the GFS. Today, in modern days, the S3 is a standard for this kind of like object storage, and everyone is using this, even though they might be running this internally. They will use some things like Minio in order to implement this. It's ETL versus ELT. When you have a structured data, you go into data warehouse, start querying. But interesting thing that happened here is that emergence of this the table formats that would be used to actually query this data. And we're gonna talk more about Iceberg in future. Maybe I will kind of like dedicate some of the additional chapter in this presentation for Iceberg type of thing. One of the problems, low latency, storage and compute disconnected, and your storage would be S3, and your compute can be run somewhere in another place. So latency of the queries would be significant. Reads are very slow. Streaming is difficult. Now, if you would thinking that you will leave this presentation with total understanding how to query stream, you will not, but you will get the good understanding what tool exists, because there's no solution, there's no right answer. And there's always a trade-offs, and we as a data streaming engineers need to understand this when we're dealing with this type of systems, and there's a lot of things going on there. Sometimes there's some things that you already have, you already know. So that's why solutions with the Kafka Connect, that's actually would be suitable, and it is okay. It's not bad thing. So it is something where you're considering, okay, let me see what I can do, a quick POC to build this system. Second thing that you start seeing is when the existing solution or something that you build on top of existing solution, on top of something that you know, doesn't really work for you because of the latency, because of your breaking SLAs with your customers, because of the high concurrency of the application, of the access to the system. So performance, for many people, it is very important consideration for many implementations of the systems. For me, community probably is the most important consideration. Like who I will go to ask this question. Any Scala people in the audience? When I tried to learn Scala, and I still have a PTSD of this, I was trying to ask questions, and I've got the response along these lines that I need to have a PhD in order to ask this type of questions and understand the functional programming and the calculus and some, I don't know, theory of relativity. In the Kafka community, on the other side, you can come, like every day there is a newbie questions and people are patiently helping people to guide them to the right location. You can find a brilliant tool, but if you're trying to get like answers or you're asking for support and the people are either arrogant or mean or something like that, you don't want this, even though they have a brilliant tool, because there are some different tools that might have a better community. And for me, for the person who was dealing and working with developers, trying to create a nice place where they can ask questions and get answers and also learn something and share this knowledge is very important for me. Now, and you have application code, you have Kafka, and now there's a area of exploration or sea of opportunity. There's some monsters there, but at least after this presentation, I hope you will get a better understanding what are, type of things that you need to consider in this. And also, this is something that I would decide to kind of like, okay, let me write this down. And you can find the bigger version at my LinkedIn, obviously. If you want to scan this link, connect with me on LinkedIn, ask your questions. I post this in one of my recent posts at the LinkedIn. And let's have a conversation. Maybe I missed something. Maybe there is something not clear for people to understand with all these technologies. So please add me to your LinkedIn. And with this, my name is Viktor Gamov, and as always, have a nice day. I think we don't have a time for questions right now, but I'm happy to answer the questions, after. I will, hang around here for quite some time because I need a train to catch because tomorrow is another presentation in another place. Thank you so much for coming.